Welcome everyone to this video. We are going to discuss some questions in uh, this uh, lecture. The first question be that of a container containing a fluid. Uh, the fluid is in equilibrium, uh, but that container is going along an incline. So let's see. Now, this container is containing fluid like this at present, um, as it should. Basically, even if a container is uh, making an angle with the horizontal, that angle being theta, the fluid adjusts itself to how the horizontal surface is. And how does it identify that what is the horizontal? It identifies by the force of gravity. So we say that gravity is that force perpendicular to which our fluid exists. Now the question is that if this container were to go along this incline with some acceleration g sine theta like this, so what will be the angle which the surface of the liquid makes with the horizontal of the container? So we can here take an idea. We know that this gravitational force perpendicular to that our liquid surface is there. Now if we were to take a pseudo force um, uh, because of this acceleration, we can say that how would we take that? So let us sit in the frame of reference of this container which is going up. So we can take a pseudo force. That pseudo force acts like this. That is how we have learned it. When we are accelerating in any frame of reference, or the frame of reference is accelerating, then we reverse the acceleration and apply it to the point at which we are studying the forces. So we reversed our acceleration and added it to the point where g is acting. So this becomes g sine theta, somewhat like this, right? Now, if this angle is theta, what would its component be along this direction, that is perpendicular to incline? It will have a component like this, that is g cos theta, right? That would be what component it makes. And the component of g uh, along this direction, that is vertically downwards, is going to be g sine theta only, right? So basically we will say, okay, we just add up all the components of acceleration, and whatever direction that effective acceleration makes with the horizontal, or makes with the this particular direction, that we can evaluate. So we'll say, okay, this value, let's say this component makes an angle some alpha with the vertical to the incline. So this alpha, we'll say tan alpha would be equal to 2g sine theta divided by the vertical, that is g cos theta. So tan alpha is equal to 2 times tan theta. So perpendicular to this uh, effective acceleration which we have got, the fluid will exist, right? So what would this angle be, right? We have to basically figure that out, because earlier the vertical, the fluid was making an angle, uh, was existing perpendicular to this vertical. Now this effective acceleration has shifted by this small angle. What is this small angle? It is alpha minus theta. So this is the angle which the surface makes with the horizontal. So this is tan inverse theta. So this is our desired result. So thank you for joining. Have a good day.